Paper 1R, June 2016, question 3. So a question about gas pressure here. You have got this first question for 2 marks, where you need to add arrows to the diagram to show the random motion of the gas particles. So that word random is the important one there. It's 2 marks, so we need 2 different ideas. So to show the random motion, the first thing you need to do is to have arrows pointing, going from the particles, but in different directions. So these arrows should all be pointing in different directions. The other second point is for having arrows that are different lengths. And again, this shows the random nature because not all of the particles will have the same amount of kinetic energy. We think about average kinetic energy when we think about gas particles. So some of these arrows should be longer and some of them should be shorter. Okay, B. So explain how the motion of the gas particles produces a pressure. This is the important bit. So when you see pressure, we should think about the definition of pressure, which is force divided by area. So just stating that will get you 1 mark. Then you can expand on it by thinking about where this force is coming from and what's causing it. So as the particles move around, what's causing the force is the particles colliding with the different sides of the container. So this colliding or collisions is a really key word that you need to get in there. And then they're quite generous here in that they have the idea that it's colliding with the sides of the container. And the reason why they're being specific about the sides of the container rather than the particles colliding with each other is it's got the word container in the question. And then mark number 4, if you needed it, but you don't, so you're only going to get a maximum of 3 anyway, is the idea that these collisions produce a force. So you're probably going to get that one or that one, but you should be definitely getting these 2 in the middle. So part C, state what would happen to the pressure if you pushed the piston into the container without changing the temperature. So if you're pushing the piston in, you're making the volume of the whole container a lot smaller. And by doing that, you're going to push all the particles closer together. And the effect of that is that it will increase the number of collisions or increase the probability that there will be more collisions. So this is only for 1 mark, so you don't need to write all of this. But if you did get an answer that was more marks and you needed to explain, not just state, it would be a smaller volume, more collisions, higher pressure. But for this question, because it is just a state question, that's the only bit that you need. Okay, moving down. So when the gas in the container is heated, the key idea, the piston moves outwards. So this idea of heating is the important one. So if you heat a gas, obviously you are increasing the temperature. And by increasing the temperature, you're also going to increase the kinetic energy of the particles, because those 2 things are linked to each other, and that's actually the definition of absolute temperature. It's the average kinetic energy of all the particles. So looking at your box, hopefully there's a couple in there that just are obviously wrong. So they've been very nice and they told you that there's 3 correct in there. So if you look at it, which one is obviously wrong? So we've already said when it gets heated, we're going to have an increasing temperature. So it's definitely not going to be that one. Another one that shouldn't make any sense, hopefully, is this one here about gas particles getting bigger. In any kind of explanation about pressure or expansion, you need to remember that the particles stay the same size. It's all about them moving apart or moving more quickly. They don't actually change size. So we don't want that one. So it should be the other three that are correct. So let's just check it. Mass of the gas particles stays the same. Yes, because we're not putting any gas particles in or taking any gas particles out. Gas particles move faster. Definitely yes. That's another way of saying that they have increased their kinetic energy. And the average distance between the gas particles increases. That one, you need to think about that idea. So the piston is moving outwards. So the particles are pushing on the piston more because they've got more kinetic energy. And the piston is allowed to move and it moves outwards. So the gas particles are going to have more space and the distance